Lesson 122 is called Permutations, another important concept you may or may not get to in Algebra 1. I think it's in that book. We just haven't reached it yet. It is something you will encounter in high school. It's a major concept. It's a unique one. We don't have a lot of other lessons related to this type of thing, but it is important. You're zoned in right now to understand the essence of what a permutation is and how you label one. I guess if I had to compare it to any lesson we've had, I would compare it to probability. So if you liked probability, thinking about how many ways something could happen, that's a lot like what we're doing today, but it is different too. If we have the letters A, B, and C, and we had, let's just imagine these first three boxes up to here as the different ways we could arrange. We could drop A into the first one, we could drop B into the second one, and we could drop C into the third one. That'd be the alphabetical way to put them in, but how many ways could we arrange letters A, B, and C in these first three boxes? I'll just keep using different colors. What if I did B first? Then I'd have to put either A or C here. Let's try A, and then I still have C. That's a new way to arrange them. But if I put B first and then do C, now I've got a third way. If I started with A like I did before, but then I follow it with C, and then I see what I'm doing? All the ways that I could do this. You can think of it this way. When I look at my first box, I have exactly three choices, right? A, B, or C. Three possibilities. In the second box, now I've got two letters left. I can't use the same letter twice. Therefore, I have how many left? Two. And finally, the last one has to go here. So the way we determine the different ways, kind of like probability, that we can arrange these boxes in order, we multiply 3 times 2 times 1, and this is called a permutation. Each way it could be arranged is called a permutation, whether it's A, C, B, A, B, C, C, A, B, B, A, C, whatever. And that's how we determine that. If 3 times 2 times 1, there are exactly 6 ways to arrange them. All 6 are shown, again, on page 388. What if I had more? Well, this what we just did works for anything. Let's say we have 5 boxes like this. And we need to put in the numbers 5, 4, 3, 2, and 1. Okay? 5, 4, 3, 2, 1. Well, that's one way I could do it, right? But then I could also do 4, 5, 3, 2, 1, right? So, same thing as the ABC. How many ways could I put a number into the first box? I have 5 total numbers to choose from. Then I have only 4 because we said you can't use the same one twice. This is a permutation. The first permutation. And how do I determine how many ways? You multiply all this together. So in the question, if there are 5 objects, how many permutations are there to arrange them in order 5 ways, or in 5 slots? 5 times 4 times 3 times 2 times 1 is 120. 120 ways 5 objects can be arranged in order if we're using all 5 and you can't use them over again. All right? There's an easier way to write 5 times 4 times 3 times 1. You can just write that with the notation, believe it or not, 5 exclamation point, which literally reads as 5 factorial. 5 factorial. If we have 10 objects, we want to find how many ways we can arrange 4 of them in a row. We can think literally, I have 10 objects, 4 spots. So I'm looking about this far. How many ways could I fill the first box? 10. How many ways could I fill the second? Well, I only have 9 numbers left. Doesn't matter that I only have 4 spots. I still have 9 choices. Now I have 8 choices. Now I have 7. I used to have trouble with these because I would get flustered thinking about all the different ways, all the different boxes. How could this work this orderly? But that's the way you have to think of it. It's a great example of in life, take it one step at a time. Start with your first box. Think, how many ways? 10 ways. Don't worry about the second box. Worry about your first box. Then the first box has helped us decide what is in the second box. So we multiply these out because there's only 4 slots. You don't need to go any further. It said 4 spots for 10 possible objects. There are 5,040 ways to arrange 10 objects 4 at a time, taken 4 at a time. How about Mary has 8 different objects? And how many permutations are possible for all 8 objects? Simple enough. There's the same number of slots as objects, so it's just going to be 8 factorial, right? Which is 8 times 7 times 6 all the way down to 1 comes out to 40,320 permutations. Can you believe that? There are 40,000 ways to arrange the numbers 8 through 1 in order. It's just insane, but it's the case. If Mary chose 3 objects at a time from her 8, in how many different ways could they be arranged? So now we're only filling them in 3 slots. What do? Any idea? It's not a full 8 factorial. It's 8, and then there's 7 ways, and then there's 6 final ways going in order, left to right. Multiply that out, and you get 336. There are 336 ways to do that. Okay? Take a look at the practice problems for the permutations. Try both of them. How many different orders can 9 objects be arranged in a row? That answer is 9 permutation, or 9 factorial. So you just have to multiply that out and tell me what that is. Give me the number. It's a big one. And then B is in how many different orders can 5 of the 9 objects be arranged in order? So now you'll only be going 5 boxes instead of 9 all the way down to 1. Make sense? Best of luck with that.